So, in response to a student question, I'm going to talk a little bit about variables. So, when researchers are trying to figure something out um, using statistical methods, variables are the things that they actually go out, the actual data that they go out and measure or record or somehow collect. So, for example, if you're a researcher and you want to study high school, say, and you want to study how the students did scholastically or academically, academic performance maybe is the thing you want to measure, but let's say the researcher then goes out and collects, you know, GPA. That would be something that maybe they would think corresponds to academic performance, or like ACT scores, SAT scores, things like that. So out of these four things, say that we talked about here, GPA, SAT scores, and ACT scores, those would be the actual variables. Those are the actual things that the researcher went and got data for. Academic performance is just sort of a concept or an idea that they're trying to model with or use these variables as a way of expressing that idea, but it's not in itself a variable. And so when you have a random variable, they come in two types. In each one of those come in two different flavors. So fundamentally, the two different families of variables are numerical and non-numerical or categorical variables. So numerical variables are basically things you can measure with numbers. So like age, weight, uh, SAT scores, things like that. They come uh, with a number. And then categorical variables are things that are uh, come in categories rather than with numerical sort of delineation. So like gender, color, maybe major in school, right? These are things that you don't measure with numbers. They you measure them with a description. So you would say male or female, or blue or red or green, um, psychology, math, English, something like that, right? And so those aren't numerical values naturally. And so out of the numerical variables, you can split those into two different camps, and those are continuous variables and discrete variables. So continuous variables are variables that it makes sense to, if you have two possible outcomes, that also all of the possible outcomes in between those values are also possible. So you have a continuum of possible outcomes. So, for example, if you go fishing and you ask how many pounds of fish did you catch, well, is it possible to get 5 pounds of fish? And sure, right? Or maybe it's easier this way. 5 pounds of fish? Sure. 6 pounds of fish? Sure. Five and a half? Okay. 5.4, 5.45, 5.453, 5.52, etc. Right? Like, so between 5 and 6, those are possible numbers of pounds of fish you could catch. But also everything in between is a possible number of pounds of fish you could have caught. Now, a discrete variable is one where you can separate out the different outcomes. They're discrete and they're separate from each other. So, how many fish did you catch? You know, five is possible, or six is possible, but there's no real natural way to catch like 5.5 fish unless you do something really weird, dynamite fishing or something. Uh, for the most part, we won't have in between outcomes. So you don't get the entire continuum of possible outcomes between 5 and 6. And so those describe our discrete variables. for our numerical variables. For the categorical variables, those come in two flavors as well. So they are ordinal and nominal. And ordinal uh, variables are those in which there's natural order, hence the ordinal order or ranking to them. So, like if you fill out a customer satisfaction report and you say, there's a question like how well, like how attentive was the service from our company, and there'll be outcomes like you know, or maybe let me rephrase. So they ask the questions like, quote, the service from our company was very good, unquote. And then, you'll be given choices like strongly agree, somewhat agree, neutral, disagree, strongly disagree, right? And so those five things, they're categories, right? They're not numbers, so that's why they're a categorical variable, but there's a natural ordering to them, right? You go from, the most positive to the most negative responses. And there's a natural way you could order that. Um, the other type of categorical variable is the nominal variable. And for nominal variables, there isn't really a natural way you can order them um, that that means anything. So if you say something like, "Oh, what's your favorite color?" and you have the choices maybe of the three primary and secondary colors, you have red, orange, yellow, green, blue, purple. You could really put those in any order and it wouldn't matter, right? Like there's not a natural way to rank those orders, those choices from best to worst. And so those are the two families of variables and the two ways you could split each family into subfamilies. And so I was asked about this first um, problem here that you see right here. And I'm not going to go through and answer all of this, but I'll talk about it, and we should, by the end of this, be able to determine ourselves what is or isn't a variable and maybe what type of variables there are. So, researchers collected data to examine the relationship between air pollutants and preterm births in Southern California. Right, so these two things, air pollutants and preterm births, those are just the things that they want to study. It doesn't, as of yet, say anything about whether or not they collected specific data called these things. So as of now, they're not variables. Right. During the study, air pollution levels were measured by air quality monitoring stations, and specifically, levels of carbon monoxide were recorded in parts per million, nitrogen dioxide and ozone in parts per 100 million, and coarse particulate matter in milligrams per meters cubed. And then length of the gestation periods uh, were collected on 1,000 or 143,196 births between 1989 and 1993. And then the air pollutant levels were calculated for each birth. Okay, so what was actually measured? So parts per million nitrogen dioxide was measured. Um, Carbon monoxide, sorry, and then nitrogen dioxide and ozone were also measured in parts per 100 million. Coarse particulate matter was measured. Length of gestation was measured. And the year was measured. And those are the only things that were actually measured that are discussed here in this problem, right? So those are the things that you could say were actual variables. Anything else that was discussed in this problem, if they didn't measure it, it's not a variable. It could be something that they wanted to study, and that by measuring these variables, hopefully reflect something about it. But unless you collect actual data on it, it doesn't count. And so for each one of these variables, or at least for the first two here, for a particular matter and the length of gestation, the question you want to ask yourself is, all right, when I describe the length of gestation or describe the level of particulate matter, can I do that with a number? Is there some number that will tell me what that is? And if it's yes, then it's a numerical variable. And the answer is no, if described via categories, then it's a categorical variable. If it's a numerical variable, you want to ask yourself, uh, if I have two different outcomes or possible numbers that could be uh, that could make sense, do all of the variables in between also make sense, or should it be like blocked out whole number values only? If if you could have values in between two values that also make sense, then that should be a continuous variable. Otherwise, it's a discrete variable. If the variable is categorical, you want to ask yourself, all right, all the different categories, is there a natural way to order them? If so, it's an ordinal variable. If not, then it's a nominal variable. All right, I hope that helps. Please, as usual, send me any questions you have on any of these problems, and I will talk to you soon.